Welcome to my video on what makes a proof trustworthy. My name is Jayson Duarte, and before we begin, let's first understand what a proof is. A proof is something that shows an idea or statement is true by using clear and step-by-step reasoning. Now, our question to create a proof will be, given a function, we need to show that that function is continuous at a specific point. And in this question, it's asking for the given function, show that it's continuous at -2. Before we begin, what is continuity? What does it mean for f to be continuous? Well, continuity means something stays smooth and connected without sudden breaks or jumps. This graph to the right shows a function that is continuous as it flows smoothly and has no breaks. Now, a strong definition will be the epsilon delta definition of continuity, which states a function f is continuous at a point A if for any epsilon greater than 0, there exists a delta greater than 0, such that if the absolute value of x minus a is less than delta, then the absolute value of f of x minus f of a is less than epsilon. Now in this definition, epsilon and delta are both arbitrary real numbers. Or it could be easier to say that they are unspecified values. A good visualization of the epsilon delta definition of continuity is shown here, where these gaps of epsilon and b and delta and a are the inequalities shown previously. But the key thing in this visualization is that for any epsilon, there has to be a corresponding delta for it to be continuous at said point. Now, back to our question. Let's prove this using the epsilon delta definition of continuity. First, given an epsilon greater than 0, we state our goal of we want to find a delta greater than 0 such that if the absolute value of x plus 2 is less than delta, then the absolute value of f of x minus f of -2 is less than epsilon. Then our next step is to compute what f of x minus f of -2 really is. Then our next step is to choose a delta and then reach the conclusion that f is continuous as long as both inequalities hold, in which this case it does with our chosen delta. Now, using the epsilon delta definition not only perfectly shows an understanding of what continuity is, but also gives the proof a clear and followable reasoning to reach the conclusion of continuity. Regardless, setting a goal or conclusion that needs to be reached and creating steps to reach that goal is good proof writing. Now, it's time to analyze AI's proofs. We will be using ChatGPT. ChatGPT is a computer program trained on lots of information that can help write, answer questions, explain things, and act like a virtual assistant. All I have to do is give the AI a prompt and it'll attempt to complete whatever I ask it. We want it to prove the same question as me, so there will be no changes. But because this is super boring to speak to ChatGPT, we made him a friend. This is Chatty. Chatty is really smart, as you can see with his business suit. Now, after asking Chatty to prove the same question as me, this is what he came up with. His first step was to simplify f of x for x not equal to -2. After he simplifies the function f, he then computes the limit as x goes to -2. Then he compares it with the value of f of -2, and lastly he reaches the conclusion that f is continuous at x equals -2. Now, this proof... Wait a minute. Hold on. limit? What went wrong with Chatty? There are actually multiple ways to show a function is continuous, but Chatty missed important steps to make sure that their logic flows smoothly with their way of showing continuity. One could say that their proof wasn't continuous. Reasons why Chatty's proof wasn't really strong is because Chatty assumed you would know why it's continuous from their proof. Chatty also never explained to you why it's continuous. Why does comparing the limit of f of x to the value of f of x at that point actually show continuity? Chatty never really explained that. And Chatty also assumed you know what limits are. What is a limit? What if we don't know what limits are? Which is a big no-no for mathematical proofs. Because of this, Chatty failed, so I eliminated them swiftly. Let's create a new AI friend that can hopefully create a better proof for us, and let's give it more detail. This is Chaz. Everyone say hello to Chaz. For Chaz's prompt, I decided to tell him that this is a college course question. I gave him the same question as Chatty and as me, but then I also asked him to prove it using the epsilon delta definition of continuity. And this is Chaz's proof. The first step was he simplified the function. Then, which I was really surprised with, his second step was stating the goal. This was really impressive, as previously Chatty never stated a goal or even a definition of what he's trying to go for to show continuity. Then, step 3, Chaz computes the expression of the absolute value of f of x plus 2. After doing so, he follows the same steps just like me. But at the end, he justifies why he reaches this conclusion by stating, by the epsilon delta definition, f is continuous at x equals -2. This proof was an absolute gem. This is also an example of why AI is super intelligent. Now, what happened with Chaz? Chaz totally mogged Chatty and created a great proof using the epsilon delta definition. However, this doesn't mean Chaz is in the clear. As great as their proof was, Chaz only gave that level of detail and used the epsilon delta definition specifically because I prompted them to do so. With my judgment, Chaz was able to create a good proof. Without it, Chaz would have probably met the same fate as Chatty. But since Chaz is still my best friend, I promised him that after this video, we'll go see the Goofy movie. Moving on, what does this mean about AI proofs in general? The problem with AI proofs is that they assume too much. Assuming too much is a big rule that is not allowed when writing mathematical proofs. If you assume too much information, then the proof itself will slowly lose the logic and proper steps to actually reach the conclusion that you are trying to reach. Another issue is that they leave small gaps of missing information in their proofs. These small gaps of missing information, sometimes people will not know. For example, Chatty used a limit. What is a limit in the first place? They just assumed that we already knew, which again, assuming too much. A third problem is that they create proofs the easiest way possible. Now, just because something's the easiest way possible doesn't mean it's the proper way. And lastly, AI proofs depend on our judgment and information to create a desired response to our prompt that we give it. If we give it more detail in our prompt and more information in our prompt, then it'll be able to use that to create a better and more desirable response. Why this matters beyond math. AI is only accurate if we know that the information told to us is accurate itself. Otherwise, it just spits out stuff that could be true or could be misinformation. For anything other than math, like science, English, or even everyday life, AI will miss important information, details, and personal judgment that we all use to accomplish tasks in these areas, and AI depends on us to feed it this information. In conclusion, AI proofs are not trustworthy because they still require human judgment, still has problems with its proof creation, and depends on humans to feed it information. Overall, I would not use AI proofs, as AI proofs are yucky, and you're probably better off just creating a proof by yourself. But anyway, thank you for watching this video. Smash that like button, and I'll see you guys next time.